say this is a solid sphere which is revolving over this axis. It has a mass m and radius is r. Mass is m and radius is r. So we know its moment of inertia about any diameter is 2 by 5 mr square. So if this is rotating with angular velocity omega about this axis, its rotational kinetic energy is half I omega square. So now what we do is, that is, suppose this is a kind of a spindle. This is kind of a spindle. This is rotating about this axis. And what we do is, we fix it on a platform. Suppose this is a platform which we have fixed and this is moving with some velocity v. So this is going to have rotational kinetic energy. Plus now center of mass is also moving with velocity v. So the total kinetic energy of this is going to be rotational kinetic energy about this axis. That is half I omega square. Plus now this is also moving this way also. That is translation kinetic energy. That is half mv square. So this is going to be total kinetic energy of this solid sphere. Now let's say we have to find the total kinetic energy of a solid sphere which is revolving about its own axis, like Earth revolves about its own axis, and it is also revolving about one other axis also, about the central axis, like the Earth revolves about its own axis also and Earth revolves about Sun also. So how to find the total kinetic energy of this body? So over here we see that this is a sphere. We have taken as a solid sphere. This could be any body. So about this axis, this is revolving with angular velocity omega 1. So one is, this is going to have a rotational kinetic energy about this axis. What is that? That is ICM, we know that is 2 by 5 mr square. So rotational kinetic energy, we know that is half I omega square. I is what? 2 by 5 mr square, where r is the radius of this. And omega square, omega 1 square, omega 1 is this. So it is rotational kinetic energy about this axis. In addition to that, this is revolving about one axis. This is also revolving about this axis also. So there is a rotational kinetic energy about this axis also, which is equal to, that is total energy is going to be rotational kinetic about this axis plus rotational kinetic about this axis. So it is half ICM omega square about this axis we have done, plus the rotational kinetic energy about this axis, that is half IYY, that is moment of inertia, will be now taken about this axis. So half IYY dash omega 2 square about this axis. It's suppose the angular velocity is omega 2. So it is going to be half IYY omega 2 square. So half ICM omega 1 square, that remains like this. Half IYY, that is moment of inertia if we have to take about this axis. So we can use parallax theorem. What is parallax theorem? That is moment of inertia about this axis is equal to ICM plus m into this distance square. We have taken this as r. So this is going to be equal to half ICM plus mr square into omega 2 square. Omega 1 is about this axis, omega 2 is about the yy dash axis. So this is going to be the total kinetic energy of this solid sphere which is revolving with angular velocity omega 1 about its own axis, and this is revolving with angular velocity omega 2 about this axis which has a radius r, capital R.